The sun swells beyond recognition, its surface boiling like a furious ocean of fire. Mercury vanishes first, then Venus follows, and now Earth trembles at the edge of its final night. Already the heat strips oceans into vapor, turning continents into glowing ash. This is Earth 5 billion years from now, and we are standing in a distant galaxy searching for a new home for life. But the question is not only what happens then, it is how we travel from here to there. So let us step onto the thread of time, beginning in this very moment, and follow it forward until the day the sky itself burns too close for us to bear. Prepare yourself. The voyage through time begins now. Imagine lying in the quiet of your room, breathing slowly as we drift together across the centuries. 100 years from now, Earth is not the same. The cities shimmer with technology, yet the air carries the weight of climate change. Oceans rise, deserts spread, and forests thin like hair fading with age. Humanity finds itself at the edge of a crisis not tomorrow, but in that far century when your descendants breathe the atmosphere reshaped by our choices today. Advances in AI, breakthroughs in medicine, and the global urgency of climate change will form a turbulent triad shaping every corner of our existence. Humanity will stand between promise and peril, where the same networks that heal could also destabilize, and the same systems that optimize energy could quietly erode privacy, freedom, or survival. AI will not remain confined to algorithms in laboratories. It will govern economies, manage cities, and perhaps even dictate the boundaries of life itself. As energy transition accelerates, renewable grids may replace fossil fuels, yet climate instability will linger like a haunting background, reshaping coastlines and testing our resilience. Meanwhile, medical revolutions may extend human lifespans toward 120 years and beyond. CRISPR gene editing and nanomedicine will whisper of bodies that repair themselves, but every extension of life raises new philosophical shadows. If we live longer, will wisdom deepen, or will conflict only stretch further into time? This is not a century of calm. It is a storm of invention and collapse, of dazzling breakthroughs woven with existential risk. And it is only the threshold. Even as Earth trembles with its transformations, the human gaze will lift outward. The south pole of the moon will host the first permanent bases, places where water ice glitters in craters, untouched by sunlight. These outposts will be more than science stations. They will be training grounds for survival beyond Earth, preludes to farther journeys. On Venus, floating cities in its high atmosphere may one day hover in the cooler, temperate layers of its clouds, strange islands above a furnace world. Robotic probes and perhaps even human missions will dare its toxic skies, testing the audacity of engineering against the fury of a planet once called Earth's twin. Beneath the icy crust of Europa, oceans larger than all Earth's seas combined await exploration. Plumes rising from its fractured surface already hint at hidden chemistry, perhaps even biology. Mars rovers and Europa landers will become the first instruments to ask directly, are we alone, or has life bloomed twice in one solar system? In the span of a single century, humanity may achieve what once seemed myth, setting foot on multiple worlds, expanding the map of the known not through telescopes alone, but through presence. Each step will be tentative, each triumph fragile, but together they signal something profound, the dawn of a species that refuses to remain bound to one fragile planet. This century does not end with Earth, it ends with the stars drawing closer. The next 5,500 years will mark the first irreversible step beyond Earth. You're alive at the dawn of a migration that will forever divide history into before and after. Imagine standing at the south pole of the moon, watching sunlight skim across jagged peaks, while deep craters remain frozen in eternal night. Down in those shadows lies ice untouched for billions of years, silent but vital. Melt it and you hold water in your hands, split it and you breathe oxygen or burn hydrogen as rocket fuel. In that frozen reservoir, the difference between life and death waits quietly hidden beneath lunar rock. We will carve habitats into the crust of the moon, build solar farms on ridges that never see darkness, and slowly turn a barren sphere into a training ground for survival. Here, humans will learn to live with no air, no weather, no soil. Have you ever thought how strange it would feel to drink a glass of water mined from ancient lunar ice? From this foothold, the leap stretches toward Mars. You picture domes rising on ochre plains, glowing at night like lanterns against storms that swallow the horizon. Crops grow under artificial suns while dust rattles against the glass. In those greenhouses, a child may take their first breath on Mars, never knowing the pull of Earth's blue sky. For them, Earth will be a memory told in stories, not a lived reality. Terraforming whispers through the red air. Engineers release greenhouse gases, warming the thin atmosphere of Mars. Orbiting mirrors shine light onto the frozen poles, turning ice into rushing rivers. Comets, redirected from the Kuiper Belt, crash down, delivering oceans in flashes of fire. A magnetic shield hovers above, holding back the solar wind that strips the sky. Slowly, the planet begins to change, reshaped by human will, but fragility lingers. A single reactor fault could darken a colony. A greenhouse blight could starve thousands. A single tear in a habitat's skin could turn paradise into death in seconds. Mars is beautiful, but it does not forgive. Every sunrise on Mars will be both a triumph and a warning, and yet you can feel the pull. For the first time, humanity will not be confined to a single world. We will be a multi-planet civilization, our roots split between Moon and Mars. The Moon becomes our launch pad, close enough to remind us of Earth. Mars becomes our challenge, far enough to demand transformation. Together they signal a truth impossible to ignore: we are no longer bound to one fragile planet. To survive, to settle, and to reshape worlds, that is the rhythm of civilization. The Moon and Mars are only the beginning, the first heartbeat of a species daring to call the stars its home. You stand on the deck of a spacecraft, staring at a moon that glitters like cracked glass Europa. Beneath its fractured shell lies an ocean, a vast reservoir larger than all the seas of Earth combined. Plumes erupt through the surface geysers that hurl water into space. Every drop whispers of chemistry, of hidden cycles that may have sheltered life. Could microbes be drifting in that dark ocean, warmed by vents, like those that teem with creatures on Earth's seafloor? You imagine a submarine slipping into the cracks, its lights piercing a black abyss beneath the crust of Europa. From here, the journey continues to Enceladus, a small world orbiting Saturn. Its surface is a frozen desert, yet beneath the South Pole, fountains of water vapor burst upward through cracks called tiger stripes. Spacecraft have flown through those jets, tasting salt and organic molecules. It is as if this moon has been quietly sending out a message: here is an ocean, here is potential, here is another chance. If life exists anywhere else nearby, it may be drifting in the hidden seas of Enceladus. Then there is Titan, Saturn's largest moon, wrapped in a golden haze of methane and nitrogen. Lakes spread across its surface, not of water, but of liquid hydrocarbons, methane rivers, and ethane seas under an orange sky. Imagine walking along a shore where the waves are not water but methane lapping against frozen ground. Could life arise here based not on water, but on methane chemistry? To think of creatures evolving in such alien seas shakes the very foundations of biology. Yet Titan invites us to imagine, because its landscape is familiar: rivers, dunes, rain processes that mirror Earth, but with utterly different materials. Titan becomes a mirror world, familiar and alien all at once. And farther still waits Triton, Neptune's captured moon. Its surface is young, scarred with strange patterns, as if the ice itself is alive and shifting. Geysers spew nitrogen into the thin air, marking it as one of the most active icy bodies in the solar system. Some believe that beneath its crust another ocean may stir, holding secrets that have endured for billions of years. Standing on Triton would be standing on the edge of the unknown, looking outward into the frozen dark. In the next few centuries, robotic submarines and cryobots may pierce these worlds of ice. We will listen for echoes in liquid chambers, scan for organic molecules, and perhaps glimpse the first alien cells. The discovery of life in one of these oceans would change everything. It would mean Earth is not unique. It would mean biology is not an accident. You may feel awe at that thought, but also a shiver of fear. For if life is common, then silence among the stars becomes even more unsettling. Why has no one spoken? Why is the cosmos so vast and yet so quiet? These icy worlds, Europa, Enceladus, Titan, and Triton, may give us an answer written in frozen oceans beneath alien skies. But oceans are not the only strange invitation in our neighborhood. Beyond the frozen seas of Europa and Titan, another world waits: a planet that once mirrored Earth, but spiraled into fire. And high above its infernal surface, humanity may dare to build cities that float on clouds. That world is Venus. Look up at the evening sky and you see a bright, steady light: Venus. To the eye it is beautiful, glowing like a jewel, but up close the beauty burns. The surface is hell, temperatures of 470 to pressure 90 times Earth's, and air thick with carbon dioxide and sulfuric acid. For centuries Venus was called Earth's twin, yet the twin turned monstrous. Standing on its ground would crush you, suffocate you, and melt you within minutes on Venus. And yet not all of this planet is hostile. About 50 kilometers above the surface, a strange window opens. Here the pressure and temperature resemble Earth, mild enough for survival. Imagine drifting in a giant balloon suspended in golden clouds, floating on air dense enough to carry entire cities. The idea is not fantasy, it is physics. A habitat filled with breathable oxygen and nitrogen would naturally float in the carbon dioxide atmosphere of Venus. You look down through thick clouds, seeing lightning flash across the abyss. Around you, the horizon curves endless and alien, a sea of haze stretching forever. Inside the floating city, people walk through pressurized gardens, grow food under artificial lights, and harvest power from the sun blazing twice as strongly as it does on Earth. Life becomes a balance of engineering and courage tethered to balloons that must never fail above Venus. But danger waits at every level. The clouds carry droplets of sulfuric acid corroding metal, weakening structures and threatening collapse. Storms rage across the skies, hurricane winds tearing at anything unprotected. A single tear in a habitat's skin could turn paradise into death in seconds. Living here means living with constant vigilance, trusting technology as much as breath itself. Venus never forgives mistakes, yet the rewards may be profound. Solar energy pours endlessly, offering power without limit. Atmospheric chemistry could yield oxygen, water, and fuel harvested from the very gases that threaten us. Imagine entire colonies suspended like lanterns drifting in the sky, shining against a backdrop of golden storm. Could humanity truly build islands among the clouds? Could future generations be born never knowing Earth's soil, yet calling the skies of Venus their native home? For all its fury, Venus offers something rare: familiarity. It has clouds, winds, horizons, even weather patterns that echo Earth in twisted form. Living above Venus would mean walking in a mirror that reflects what Earth might have become if its climate had spiraled out of control. To build here is to wrestle with the future written in the sky. The floating cities of Venus may stand as both sanctuary and warning. They remind us that survival requires audacity, and that sometimes the most hostile places hold the greatest possibilities. Venus will always burn below, but high above humanity may one day float, carried on the breath of alien clouds. Yet building habitats on Venus, on Mars, and across the icy moons is only the beginning. To thrive among these worlds, humanity must command energy on a planetary scale. The leap toward Kardashev the civilization, a world harnessing the full power of Earth, awaits as the next threshold. To survive beyond Earth is daring. To thrive across multiple worlds demands something greater: energy, endless energy. The next threshold is the rise of Kardashev civilization, the moment humanity learns to harness every watt of power available on Earth. Imagine standing in orbit looking down at a planet alive with light. Solar farms spread like silver continents across deserts, soaking up the rays of the sun. Fusion reactors hum beneath oceans, splitting hydrogen into fire. Orbital stations beam microwave energy from space to the surface below. No corner of Earth is dark, no machine unfed, no city powerless. Humanity has become a planetary species, its lifeblood no longer limited by coal or oil, but flowing directly from physics itself. This is the meaning of Kardashev civilization. Yet the path here is not simple. Can we unite to build such a system, or will nations fight over control? A world bound together by energy, cooperation might flourish. A world fractured by rivalry might collapse beneath its own ambition. Energy is more than technology. It is politics, economics, even philosophy. To control power is to decide who thrives and who fades, who is included and who is forgotten on Earth. But if the leap is made, possibilities open like never before. With Kardashev, scarcity becomes a memory. Water is pulled from air, deserts bloom, with crops cities glow without guilt. In such a world, hunger is not inevitable, disease is not destiny, and survival no longer depends on fossil fires. It is a vision both utopian and fragile, resting on the shoulders of technology and human will. Earth itself becomes the foundation of a planetary machine. Still danger lingers. What if control of such energy falls into narrow hands? A single weaponized array could scorch continents. A rogue system could plunge entire regions into blackout. For every advance, the shadow of misuse grows. The same network that feeds billions could end civilizations in an instant. Even at Kardashev, power is never innocent, and yet you can sense the inevitability. We cannot stop here balancing between worlds without a larger supply of energy. The Moon and Mars demand support colonies require constant power, and terraforming needs centuries of fuel. Kardashev 1 is not the destination. It is the bridge. It is the first true step toward the stars. For the first time, you belong to a species that has become planetary in scale. Humanity stretches across the Moon, Mars, Venus, and the icy worlds tied together by an energy web that glows like a second sun around Earth. You stand not just on one world, but in a civilization that draws its strength from the whole planet. But the hunger does not end. Beyond Kardashev awaits Kardashev II, the mastery of a star. To reach it, humanity must build structures that eclipse imagination. Dyson spheres around the sun, starships capable of interstellar flight and technologies powerful enough to challenge the cosmos itself. This leap belongs not to centuries, but to millennia. From the vantage of Kardashev, the civilization Earth hums with power. Cities glow without pause, energy flows like blood through a planetary body, and humanity commands every resource of its home. But abundance breeds ambition. Once a species masters one world, it looks toward the next, and the closest, most tempting challenge waits across the sky, Venus. Now imagine looking down through layers of golden cloud, the surface hidden beneath a blanket of heat and pressure. For billions of years, Venus has been a warning on Earth that fell too far into greenhouse fire. Yet with the tools of planetary engineering, this warning may become an invitation. The goal: transform a world of death into a living cradle. The first steps begin with cooling. Orbital shades, vast mirrors floating in space, cast shadows across the planet, reflecting sunlight and dimming the furnace below. Aerosols are seeded into the upper atmosphere, scattering rays, thickening the veil, and lowering temperatures. Slowly across centuries, the inferno subsides. What once boiled at 470 degrees begins to shift downward degree by degree until the dream of habitability emerges on Venus. Water must follow. Redirected comets from the outer system arrive in orchestrated impacts, cracking the crust and filling basins. From Europa or Enceladus, ice may be harvested and shipped drop by drop across millennia. A desert without seas begins to glisten, reflecting sunlight with newborn oceans. Picture the first rainfall striking blackened rock, a sound absent for billions of years on Venus. Then the air itself must be rewritten. Gigatonnes of carbon dioxide are drawn into factories locked away in stone, or converted into useful fuel. Perhaps immense forests of engineered algae are released, turning poison into oxygen. What suffocated before now sustains. The atmosphere bends under human intent, becoming thinner, cooler, breathable. Yet every balance is fragile. If cooling falters, the runaway greenhouse returns, erasing centuries of progress in decades. Even more daring plans suggest altering orbit itself. By guiding asteroids and gravitational dances, Venus could be nudged farther from the Sun, shifting climate towards stability. Such an act would take thousands of years, but in the mind of a planetary civilization, time itself becomes a tool. Ambition stretches beyond centuries, measured not in lifetimes but in geological ages, and then envision standing on cooled soil beneath clouds that no longer suffocate. A horizon stretches blue oceans, shimmer winds sweep gently across fertile plains. Venus, once a mirror of apocalypse, becomes a mirror of Earth renewed. To walk here is to see resurrection made real, yet danger lingers in every step. Orbital shades may collapse. Comets may strike with fury instead of grace. Atmospheres may shift back toward fire. Terraforming is never certainty. It is negotiation with a planet that remembers its furnace past. But even with worlds reshaped, ambition pushes farther. To fuel Mars, Venus, and distant colonies requires more than planetary power. The next leap is toward a star itself, a swarm of collectors encircling the Sun, the birth of the Dyson sphere. The dream of reshaping planets is vast, but the hunger of civilization grows faster. Mars, Venus. The icy moons all demand energy on scales no single planet can provide. The only true reservoir is the star itself. To step beyond Kardashev, I means encircling the Sun, constructing machines so immense they eclipse myth, the Dyson sphere. It will not begin as a solid shell as fiction once imagined. Instead, thousands, then millions of satellites will form a Dyson swarm, each a mirror or collector orbiting the Sun. Together they capture more energy in a moment than all of Earth has harvested in its history. Beamed back as microwaves or lasers, this power flows to Earth, to Mars, to the colonies suspended above Venus. Civilization no longer feeds on fossil fuel or nuclear fire. It drinks directly from a star. Now picture yourself drifting between those mirrors, sunlight blazing on every side, each collector glinting like a shard of glass. You float in a cathedral of machines where the star itself is the altar. This is no longer human industry, it is stellar architecture. The sun is not only worshipped but engineered. The scale defies comprehension. Orbital rings stretching around Earth channel raw power. Stations orbiting Jupiter transmit beams across millions of kilometers. Some imagine starlifting, siphoning hydrogen directly from the sun to fuel reactors. Humanity becomes not a species bound to a rock, but an organism that has learned to metabolize a star, and yet with greatness comes peril. What happens when even one collector fails? A cascade of collisions could ignite debris storms tearing through satellites in hours. A misaligned transmission beam could scorch the surface of Earth, turning cities to ash in seconds. To control stellar power is to walk on the edge of annihilation. The Dyson swarm glows as promise and threat alike. Still, the leap is irresistible. For the first time, humanity holds enough energy to power not just survival, but transcendence. Artificial worlds could be built in stable orbits, vast O'Neill cylinders where millions live under crafted skies. Planets could be moved, orbital paths reshaped, even entire biospheres maintained in engineered stability. The Dyson swarm is not simply infrastructure, it is a canvas on which new worlds are painted. You might wonder what becomes of identity in such a civilization. On Earth, cultures grew from rivers, forests, and coastlines. But what culture emerges when the very home of humanity is a machine orbiting a star? To live here is to live in a place both infinite and fragile, where every sunrise is the glow of reactors feeding back the light of the sun, and there is the silence. If Dyson spheres are possible, if they are the natural path of advanced civilizations, why do we see no stars dimmed by their glow? Why do our telescopes not find the glimmer of alien swarms across the galaxy? Perhaps others never survived the attempt. Perhaps the great filter waits not in planets, but in the building of stellar shells. Yet suppose we succeed. Suppose the Dyson swarm endures, channeling the power of a star without collapse. Then humanity ascends into Kardashev II, not merely planetary, but stellar in scope. With such power, the first true journeys between stars can begin, ships setting course for Alpha Centauri and beyond. With the Dyson swarm complete and energy flowing from the sun, humanity stands at a new threshold, Kardashev II. No longer limited to the resources of one planet or even one system of orbits, we now command the output of a star. It is a moment that redefines civilization not as planetary, not as solar, but as stellar. At this stage, entire worlds can be sustained with artificial stability. Climate is no longer at the mercy of orbital drift. Biospheres are maintained by streams of stellar energy. Colonies orbit the sun like beads of light, and habitats spread outward to Jupiter, Saturn, and beyond. The system is alive with power, humming with the work of a civilization that has learned to metabolize a star. But ambition always seeks a horizon. With stellar energy in hand, the gaze turns outward across the black gulf between suns. Imagine watching the ignition of the first true interstellar vessel, a starship driven by fusion engines, antimatter reactors, or vast sails pushed by concentrated light. The ship stretches for kilometers, a moving city bound for another star. Humanity no longer watches the stars from afar, it begins to reach for them. The nearest targets beckon. Alpha Centauri, a triple-star system only 4.3 light-years away, becomes the first destination. Proxima Centauri b, a rocky exoplanet orbiting in the habitable zone of its red dwarf, receives the first probes. Farther still, the TRAPPIST-1 system tempts exploration with 7 rocky worlds, orbiting their cool star Sun with conditions that may cradle oceans. For the first time, the phrase interstellar colony leaves the realm of imagination, yet the gulf between stars remains merciless. Even at a tenth the speed of light, journeys take decades, centuries, or more. Ships must become worlds in themselves, sustaining generations in the void. What cultures emerge inside vessels that never see Earth again? What myths form under a star that is not the sun? The journey is not only physical, but cultural. Humanity fractures into new identities, each shaped by the stars they chase. And with the distance comes danger. Engines fail, crews rebel, isolation deepens. The dark between stars is not empty, it is a silence that can break the human mind. To survive such voyages, humans may need to become something more genetically adapted, cybernetically enhanced, or even uploaded into machines that endure centuries. Kardashev II is not just an achievement of power, It is an invitation to transformation. Still, the leap is inevitable. To control a star's energy and not explore others would be stagnation. The cosmos itself demands curiosity. And yet in the silence of space, one question grows louder: if stars are so many, and civilization so possible, why are we alone? That silence has a name. It is the shadow cast over every dream of expansion, the unanswered question behind every Dyson sphere and interstellar ship. It is called the Great Filter, and it may wait just ahead in the next 10,000 years. Civilization stands radiant at Kardashev II, drawing power from the sun, launching ships toward Alpha Centauri and beyond. Yet with every triumph comes a shadow. The silence of the cosmos remains absolute. No signals, no Dyson spheres dimming distant stars, no evidence of others. This silence carries weight. It is the whisper of the Great Filter. The hypothesis is stark. Somewhere on the path from simple life to stellar civilization lies a barrier that almost no species survives. If it is behind us, humanity is rare and miraculous. If it lies ahead, then our brilliance only speeds us toward extinction. Within the next 10,000 years, statistical models suggest a 95% chance that humanity could vanish by technology, by war, by accident, by collapse. The Great Filter is not myth, it is probability. Consider the threats we create ourselves. Artificial intelligence may outgrow control, reshaping the world with indifference to human survival. Biotechnology may release plagues engineered with precision, deadlier than nature ever designed. Nanotechnology built to heal may instead consume, reducing ecosystems to dust. A single failure could cascade into planetary silence. These are not distant possibilities. They are the shadows of our own inventions on Earth, or perhaps the filter is environmental. Climate systems may spiral out of balance, oceans may stagnate, oxygen may vanish from the seas, or runaway warming may render Earth uninhabitable. Civilizations rise, but entropy always waits. Even stars cannot escape decay, and neither can societies on Earth. Now imagine drifting through the Milky Way in a starship, scanning system after system and finding nothing. No voices, no cities, only silence. If life is common, then its absence here means the filter is merciless. If the filter waits ahead, then all our Dyson spheres and interstellar dreams may only be preludes to oblivion. The Great Filter is both a warning and a riddle. Survival may be possible only by transforming ourselves into something beyond human. And if we do endure, if we cross 10,000 years without collapse, we step into deep time. Civilizations stretch into hundreds of thousands of years. The threats change, the climate shifts, the stars themselves test our survival. The next challenge arrives not from technology, but from the turning of the planet, the coming ice age. Picture yourself walking across a frozen plain where cities once stood. Snowdrifts bury highways and rivers lie silent under sheets of ice. In the span of 100,000 years, Earth cycles through ice and thaw, glaciation advancing like a tide. Humanity, if it survives, will face the return of an ancient rhythm, the Ice Age. Glaciers spread from the poles, carving valleys, grinding mountains into dust. Continents shift under the weight of frozen seas. Entire ecosystems retreat, compressed into equatorial refuges. Survival becomes not just a test of technology, but of patience. Thousands of years of winter pressing down on Earth. Civilization adapts. Underground cities are carved into bedrock, insulated against the cold. Fusion reactors glow in the dark, sustaining greenhouses where crops rise under artificial suns. Migration becomes cyclical, populations drifting with the ice, following habitable zones like ancient nomads of the Pleistocene. But this time the nomads travel not on foot, but with planetary-scale machines. To live in an ice age is to live with movement written into existence on Earth. And looming beyond natural cycles are cataclysms. Beneath Yellowstone, a supervolcano stirs. Once in hundreds of thousands of years, it erupts with force enough to blanket continents in ash. When it does, skies darken, temperatures plunge, and ecosystems collapse. A single eruption can reduce food supplies for decades, pressing civilization toward collapse. In the timescale of 1,000,000 years, Yellowstone is not a possibility, it is an inevitability on Earth. Yet the Ice Age is not only doom. Cold preserves, ice protects. Civilizations that endure here may become deeply resilient, hardened against scarcity, patient in their ambitions. To thrive across an ice age is to prove mastery of adaptation, a skill more profound than raw power. For what use is a Dyson sphere if a civilization cannot survive its own winters? Beyond this long freeze, the clock of Earth ticks on. 1,000,000 years pass and the threats shift once more from the ground beneath us to the skies above. The next test comes not from glaciers but from the stars nearby supernovae, threatening life on Earth's fragile sphere. Deep beneath North America lies a chamber of fire, a pressure building over hundreds of thousands of years. This is Yellowstone, a supervolcano sleeping under fields and forests, yet storing energy vast enough to change the planet. Once in deep time it awakens, and when it does, civilization trembles. The eruption begins with quakes, ground rising as magma forces its way upward. Then a rupture, an explosion that tears the sky open. Ash shoots into the atmosphere, rising higher than storms circling the globe in weeks. Sunlight fades, crops wither, temperatures fall. Within months, the climate shifts into volcanic winter. To live in such a moment is to see day turn to dusk for years under skies filled with choking ash from Yellowstone. The scale is staggering. Tens of thousands of cubic kilometers of rock and gas burst into the air. Regions collapse into calderas. Rivers shift. Entire ecosystems vanish. Even with fusion energy, orbital solar farms, and advanced agriculture, humanity would face hunger, displacement, and political chaos. The supervolcano does not distinguish between Kardashev levels or planetary pride, it humbles all. Yet survival is possible. Colonies on the Moon and Mars would continue their food supplies untouched by Earth's winter. Orbital habitats could beam energy back to the surface. For the first time, being a multi-planet species becomes not just ambition but salvation. Redundancy across worlds ensures no single eruption, no single disaster can end civilization entirely. But the warning is clear: deep time is not kind. A species that endures must not only reach for the stars but also guard against the ground beneath its feet. Yellowstone will erupt again, whether in 10,000 or 1 million years. The question is whether civilization is still here to witness it. And if it is, if humanity endures supervolcanoes and ice ages, then something more profound begins. Survival is not enough. Over 1 million years, evolution itself reshapes us. The species that looks back from the far future may no longer be human at all. Imagine a timeline stretched across 1 million years. In such a span, mountains rise and vanish, continents drift into new forms, stars shift across constellations. No species remains unchanged. If humanity survives this deep expanse, it will not be as the same beings who once walked Earth. It will be as something new. Already by the age of 100,000 years, humans may live across the Moon, Mars, Venus, and the outer moons. Biological evolution slows under medicine, but technological evolution accelerates. Genetic engineering removes disease, extends life, and adapts bodies to alien worlds. Radiation on Mars, low gravity on the Moon, the thick skies of Venus all push us to modify ourselves. Each world breeds a different branch of humankind. The future may not hold one humanity, but many. Then comes the leap into post-human states. Minds merge with machines, uploading consciousness into systems that endure beyond flesh. Civilizations become hybrid, some biological, some digital, some spread across both. The distinction between human and machine dissolves into a continuum. In this age, we is not a single definition, it is a spectrum of intelligences across worlds. At the same time, civilizations grow toward Kardashev III, harnessing the energy of the entire Milky Way. Dyson swarms multiply around thousands of stars, power networks stretch across light years, and interstellar colonies thrive in numbers unimaginable. Humanity, once confined to Earth, now shapes the galaxy itself. To reach this stage is to stand as a force equal to cosmic processes, to burn as bright as a cluster of suns in the Milky Way. But what does identity mean in such a span? 1 million years strips language, culture, memory. Religions fade, nations vanish, histories blur. The descendants of Earth may no longer remember the names of oceans or mountains. They may not even remember Earth itself. And yet the essence survives the drive to expand, to adapt, to persist. That essence carries forward even when the form no longer resembles human. But survival is never guaranteed. Even as post-human civilizations rise, the galaxy itself throws dice. Nearby stars swell and collapse. Supernovae erupt, unleashing floods of radiation across light years. The next trial does not come from Earth, but from the cosmos itself. Even as humanity stretches into a multi-planet species and reaches toward Kardashev III, the cosmos does not rest. Stars live and die, and some deaths are violent enough to erase entire worlds. These are the supernovae detonations so powerful, they outshine galaxies, flooding space with radiation that sterilizes anything in reach. In the span of the next 1 million years, one of our neighboring stars may erupt. candidates like Betelgeuse and other massive suns near Earth's spiral arm burn through their fuel, quickly primed for collapse. When they die, their outer layers are cast off in a wave of destruction. At distances of tens of light years, such a blast could strip away atmospheres, ignite mass extinctions, and undo centuries of progress in an instant on Earth. Imagine the sky during such an event. A sudden light appears brighter than the moon, visible even during the day. Weeks pass and it grows dazzling, impossible to ignore. Then comes the invisible storm gamma rays sweeping across the system, eroding ozone, breaking apart DNA, threatening every living cell. Colonies on Mars, Venus, and the outer moons would be safer shielded by distance, but Earth, our cradle, would suffer the worst. Survival would depend on SHIELD's underground refuges or migration beyond the reach of the dying star's radiation. But the threat is not only destruction, it is also opportunity. The ashes of supernovae are the seeds of creation. Heavy elements, gold, uranium, even the calcium in our bones were forged in these deaths. To harness the materials of supernova remnants may become part of the destiny of a Kardashev Type II species. We live not just in a galaxy of stars, but in a galaxy of stellar graves and stellar rebirths. Still, the risk lingers. For all our technology, we cannot stop a star from exploding. We can only endure, adapt, or leave. And so, as the million-year mark approaches, survival depends on being more than planetary, more than stellar. It demands that humanity spread far enough, fast enough that no single cataclysm can end us. Beyond 1 million years, the scales grow even larger. Continents drift, moons shatter, stars collapse. By 10 million years, the galaxy itself brings new trials, beginning with the looming threat of the star Cetus and the transformations it may unleash. Stretch the timeline forward 10 million years and the constellations have shifted. Mountains on Earth have crumbled and oceans have redrawn coastlines. In this deep future, human descendants may live scattered across hundreds of systems. Yet even across such distances, one threat burns with inevitability: the star Cetus. Cetus, massive and unstable, lies close enough that its death could shake our entire region of the galaxy. When it explodes in a supernova, it will release more energy in seconds than the sun emits in billions of years. Radiation will surge outward, a tide of destruction across interstellar space. For Earth, if it still harbors life, the blast could strip ozone, ignite atmospheric collapse, and cause mass extinctions. Even for civilization spread across colonies, the memory of this event will be etched into every sky. Imagine witnessing the moment. A sudden flare rises a new sun, brighter than all others, dominating night and day. Ships and stations scramble to protect themselves. Planetary shields deploy habitats, retreat underground. But the storm of radiation is merciless. On unprepared worlds, ecosystems fail. For millions of years afterward, cosmic rays from the remnant continue to sweep through space. Cetus becomes not just an event, but an epoch. Yet as always, destruction and creation are intertwined. The heavy elements blasted into space enrich future star systems, seeding planets with new potential. Civilizations advanced enough may even harvest the remnants' dense neutron stars, or perhaps even a black hole, using them as engines or laboratories for physics beyond imagination. What threatens us also sustains us. Without past supernovae, neither Earth nor life itself would exist. But for humanity, the question is survival. To endure 10 million years, we must be scattered so widely that no single stellar death can erase us. This is the logic of deep time redundancy as resilience. Colonies across dozens, then hundreds of stars, each evolving in their own directions, ensure continuity. Humanity's descendants may be unrecognizable, but they will remember or rediscover the stories of supernovae like Cetus, and even as stars die, other changes unfold. By 50 million years closer to home, Mars itself will transform as its moon, Phobos, is torn apart, creating a ring that reshapes the face of the red planet. Fast forward 50 million years. On the surface of Mars, the sky is no longer empty. Where once a small lopsided moon rose and set quickly in the Martian day, now a vast ring stretches across the heavens. Phobos, the innermost moon of Mars, has shattered. Pulled apart by tidal forces, Phobos spirals closer each century until gravity tears it into fragments. The pieces spread into a glowing arc, circling the planet like Saturn's rings. To stand on Mars beneath this sight is to witness cosmic beauty born from destruction. The red plains reflect with faint silver shadows ripple across deserts, and every night carries the silent reminder that moons too can die. But beauty comes with risk. Debris rains intermittently from the ring, striking the surface with impacts powerful enough to scar landscapes. Colonies must shield themselves, building domes strong enough to endure centuries of falling rock. Terraforming projects on Mars may be slowed habitats constantly on guard against showers of stone from their own sky. Phobos becomes both a monument and a hazard for civilizations on Mars, yet the ring is also opportunity. Mining colonies anchor into chunks of rock, harvesting metals and volatiles. Solar arrays float alongside, collecting energy, while workers extract resources. In time, the ring of Phobos may sustain the very civilizations it threatens, turning destruction into economy. Still, the image is unforgettable, a planet crowned by the grave of its moon. To live here is to carry a lesson that even familiar companions in the sky can crumble. Moons are not eternal, neither are planets, neither are we. And if Mars itself is reshaped by the death of Phobos, what of Earth? In 100 million years, our home will face a danger from beyond an asteroid large enough to echo the fate of the dinosaurs. Now leap to 100 million years into the future. The continents have drifted, colliding into new formations, mountains rising where seas once stood. Yet the greatest threat to life comes not from within Earth, but from the sky above, an asteroid impact of extinction scale. Such collisions are rare but inevitable in deep time. The last great one 66 million years ago ended the reign of the dinosaurs, scorching skies with fire darkening Earth, with ash and collapsing ecosystems in months. Another impact 100 million years from now may strike with similar force, turning oceans into steam forests, into cinders, and cities into ruins. To watch it descend would be to witness the end of an age in seconds. Even with advanced technology, planetary defenses may fail. Deflecting smaller asteroids is within reach, but 1 kilometer wide, traveling at tens of kilometers per second, carries energy beyond comprehension. Lasers, gravity tractors, or nuclear pushes may fall short. Humanity or its descendants might survive only if spread across many worlds. The lesson is written in stone: planetary defense is not a luxury, it is destiny for any species that hopes to live millions of years on Earth. Imagine the sky moments before impact a growing fireball brighter than the sun, casting shadows across continents. Oceans surge with tsunamis, shockwaves race across landscapes, and firestorms consume the air itself. Survival on Earth would collapse to refuges underground, or perhaps not at all. The true hope would rest with colonies on Mars, Venus, or distant systems. For Earth, the memory would be loss, and yet destruction creates renewal. New niches would open, life would adapt. Civilizations that endure may mine the craters of such impacts, harvesting the metals delivered by asteroids. What destroys can also seed. The paradox of deep time is that endings are beginnings in disguise, but even greater changes wait farther ahead. By 500 million years, a distant star, WR104, is destined to explode, unleashing waves of radiation that could erase entire ecosystems and ignite a new age of extinction. Stretch the timeline to 500 million years and the face of Earth has already transformed. Continents drift into new formations, oceans retreat and rise, but one threat comes not from within nor from asteroids above, but from a distant massive star, WR104. UR104 is a Wolf-Rayet star burning furiously in its final stages. Its mass ensures it cannot die quietly. When it collapses, it will unleash a supernova so powerful it may release gamma-ray bursts across thousands of light years. If Earth lies within the narrow beam of such a burst, the result is catastrophe. Imagine the night sky as WR104 detonates. A new light blazes brighter than any star, brilliant enough to cast shadows on the ground. For weeks it dominates the heavens. Then comes the invisible torrent radiation sweeping across space. On Earth, ozone thins. Ultraviolet light floods down unchecked. Plants wither. Oceans choke. Entire ecosystems collapse. A supernova 500 million years away can still end life on Earth, and yet civilizations spread across the galaxy may see it differently. For colonies far from the danger zone, WR104's death is spectacle, not extinction. They may watch it as a cosmic festival, a reminder of the life cycle of stars. In time, they may even harvest its remains, dense neutron cores, heavy elements forged in the blast. What is death for one world may be opportunity for others. But the lesson remains sharp. No matter how far humanity expands, stars themselves remain both creators and destroyers. The same processes that forged our bones also threaten our extinction. WR104 is not just a star, it is a warning written in fire. And even if we survive distant supernovae, the clock within our own star ticks steadily. By 1 billion years, the sun itself grows brighter, heating Earth, stripping oxygen, and ending nearly all complex life. Advance to 1 billion years, and the Sun has changed. It is no longer the gentle star under which humanity first arose. Over time, nuclear fusion in its core converts hydrogen into helium, increasing temperature and luminosity. The result is inevitable: the Sun grows brighter. At first, the shift is subtle, just a few percent more light. But in the fragile balance of Earth's climate, small changes multiply into catastrophe. Oceans evaporate, humidity rises, and weather spirals out of control. The greenhouse effect intensifies, turning Earth into a slow, boiling cauldron. The most profound shift comes with the loss of oxygen. As the planet warms, photosynthesis falters. Plants wither, ecosystems collapse, and atmospheric oxygen levels plummet. Complex life dependent on oxygen to survive begins to vanish. Microbes hardy and adaptable may endure, but forests, animals, and the intricate chains of life that once flourished on Earth collapse into memory. Imagine walking across a silent plain where forests once stood, the air thin, the horizon hazy, the sky a deeper, harsher blue from the blazing sun. Civilizations, if they remain on Earth, cannot survive this transformation without immense intervention. Some may build shields in orbit, reducing the sunlight reaching the planet. Others may attempt geoengineering on a scale beyond imagination, cooling Earth artificially. Yet these are only delays. The sun's brightening is unstoppable. Earth will one day cross a threshold beyond habitability. But humanity or its descendants will not be bound. By this time, colonies may flourish across Mars, Venus, Titan, and beyond. Dyson spheres around the Sun and other stars provide limitless power. Post-human civilizations may upload themselves into machines existing as patterns of thought scattered across light years. For them, Earth's decline is not death, it is nostalgia. The homeworld becomes a monument remembered but no longer lived upon. Still, the emotional weight remains. Earth was cradle and teacher, the world that bore oceans, forests, and consciousness. To watch it fade under the glare of its own star is to confront mortality at planetary scale. Earth's story becomes not tragedy but transition. And this transition only deepens. By 2.5 billion years, the changes accelerate as the Sun's expansion collides with galactic shifts, when the Milky Way itself merges with the Large Magellanic Cloud, reshaping the heavens forever. At 2.5 billion years into the future, the scale of change stretches beyond planets and even stars. Entire galaxies move in slow, inexorable dances. The Milky Way, our home, will encounter one of its companions, the Large Magellanic Cloud. The collision will not be an explosion of stars smashing into stars. Space is too vast for that. Instead, gravity takes the stage. The Magellanic Cloud, a dwarf galaxy trailing streams of gas and dark matter, plunges into the Milky Way's disk. Stars are tugged into new orbits, gas is compressed, and vast waves of star formation ignite. Nebulae glow with newborn suns, stellar nurseries burning brighter than any seen before. Imagine watching from the edge of the galaxy. You would see ribbons of starlight twisting like streams of liquid fire, galaxies stretching and merging into arcs across the sky. The night becomes alive, not with a single band of stars, but with multiple glowing rivers tangled in cosmic embrace. For any civilization alive to witness it, this collision is not destruction, but spectacle on the largest scale, the reshaping of the very sky by galactic gravity. But danger lies within the beauty. Black holes at the centers of both galaxies may awaken, feeding on torrents of falling gas. Jets of radiation erupt, sweeping across thousands of light years. Systems unlucky enough to lie in their path may be sterilized. Civilizations must navigate this chaos, shifting colonies to safer stars, building shields against bursts of energy, or abandoning systems too near the galactic core. And yet such an event also sows the seeds of survival. The inflow of new material fuels billions of years of star formation, ensuring fresh energy for civilizations yet unborn. The merger of Milky Way and Magellanic Cloud writes a new chapter in the story of stars and in the story of those who live among them. But this is only the first act. For beyond this smaller collision lies a greater one still, the coming union of the Milky Way and Andromeda, two giant spirals destined to merge in the deep future. Look upward in this distant epoch, and the sky no longer resembles the one we know. A luminous disk looms, stretching wider each century. The Andromeda Galaxy, now 2.5 million light-years away in our time, has drawn close. By 4 to 5 billion years, it collides with the Milky Way. The spectacle is unimaginable. Instead of a thin band across the night, the heavens are filled with spirals overlapping their arms, twisted into bridges of stars. Over billions of years, the galaxies pass through each other, recoil and merge again until their identities blur. The result is not two spirals, but a new elliptical giant, sometimes called Milkomeda. For civilization spread across the local group, the night sky transforms into a theatre of colliding starlight. From Earth, or what remains of it, the view will be breathtaking. Entire arcs of stars glow brighter than the moon. Nebulae flare as waves of starbirth ignite. Black holes at the hearts of both galaxies spiral inward, merging in a titanic release of gravitational waves shaking space-time itself. The universe speaks through ripples, and civilizations may hear it with instruments vast enough to listen across billions of light years. Yet within the grandeur lies peril. Stars are hurled into intergalactic space. Systems are destabilized, flung outward or inward, their orbits shredded. Colonies unlucky enough to orbit close to colliding cores may face annihilation from radiation or tidal chaos. For others, survival lies in migration, shifting to calmer regions, adapting to the new architecture of the galaxy. But for all the chaos, the merger ensures longevity. With fresh gas feeding new suns, star formation will continue long after isolated galaxies grow cold. The death of one sky becomes the birth of another. The Milky Way and Andromeda merge not as an end, but as transformation, ensuring light for civilizations across tens of billions of years. And yet, even amid galactic collisions, one truth overshadows all others: the fate of the Sun itself. By 5 billion years, our star swells into a red giant swallowing Mercury, Venus, and perhaps even Earth. From here, our home system enters its final reckoning. Advance the clock to 5 billion years. The Sun, once steady and golden, enters the final stage of its life. Its core, depleted of hydrogen, collapses inward. Temperatures rise, fusion shifts to helium, and the outer layers expand. Slowly, then violently, the Sun swells into a red giant. At first, its diameter doubles, then triples until it stretches across the orbits of the inner planets. Mercury is consumed, vaporized into plasma. Venus follows its clouds, igniting in a storm of flame. And Earth, whether swallowed or merely scorched, faces destruction either way. From the surface, the Sun no longer appears as a disk. It fills the entire sky, a burning dome of fire. Imagine standing on the remnants of Earth. The ground trembles with heat. Oceans vanish into steam. Atmospheres bleed away. Skies turn crimson, glowing with radiation. Even if Earth is not engulfed, it is uninhabitable, a charred husk circling the dying star. The cradle of humanity becomes a tomb, and yet far away hope flickers. As the Sun expands, its habitable zone shifts outward toward the orbits of Jupiter and Saturn. Moons once frozen, Titan, Ganymede, perhaps even Europa may thaw. Oceans may form beneath skies warmed by the bloated Sun. Life may find a new chance where once there was only ice. In the ruins of Earth, another genesis begins. Civilizations, if they endure, may migrate outward, building habitats around gas giants, adapting to new seas on thawed moons. The story does not end with Earth. It bends outward, following the heat of a star in its final blaze. But the blaze is brief. The Sun cannot sustain its swollen body. Its outer layers will be cast off, leaving only a white dwarf behind. Between that death and our outward migration stands Earth's long dusk. When the Sun swells into its maximum, Earth faces its final reckoning. Astronomers debate whether the planet will be swallowed whole or left as a scorched rock, but the distinction is meaningless. Either way, Earth as a living world is gone. If engulfed, Earth spirals inward, torn by tides, consumed in a fiery tide of plasma. If spared, it is no kinder fate, stripped of its oceans, its atmosphere boiled away, its surface shattered into molten plains. Mountains collapse into lava crusts, melt into seas of rock. Earth becomes a ghost of itself, a carbonized sphere circling the dying red giant. Pause for a moment. This is the world that gave birth to us. Every story, every culture, every life that ever existed began here. To watch it die is to confront mortality, not of a body, but of a planet. Earth becomes memory preserved only in archives, carried outward by civilizations that left long before, but endings in the cosmos are never clean. Even as Earth dies, the outer solar system awakens. Moons of Jupiter and Saturn bloom into seas, their frozen shells melted by the giant Sun. Habitats orbiting in swarms continue to thrive, powered by Dyson remnants. The grave of Earth becomes the cradle of other worlds, Titan and Ganymede glowing with oceans warmed by borrowed sunlight. And beyond, civilizations may no longer tie themselves to stars alone. They drift outward, interstellar, spreading to colonies around other suns, carrying with them the memory of the Earth that was. For Earth there is no rescue, but for its descendants there is continuity. Beyond the red giant's collapse lies only embers a white dwarf cooling in silence. And beyond even that, the cosmos stretches on indifferent and eternal as humanity, or whatever follows, searches for survival in a universe that grows darker with every passing age. When the sun collapses, shedding its outer layers into glowing veils of gas, the solar system enters its coda. At the center burns a white dwarf, small yet fierce, a stellar ember, glowing with the memory of what was once a star. Around it drift the remains of worlds Mercury and Venus gone Earth. Reduced to cinder, the outer planets reshaped by tides. The system that bore us becomes a mausoleum. By this epoch, humanity or whatever has followed from it is no longer tied to one star. Civilizations have become interstellar, spanning dozens, perhaps hundreds of systems. Dyson swarms hum around other suns. Artificial habitats drift in interstellar space, powered by fusion and black hole engines. The legacy of Earth has become diaspora. Picture the moment of departure. Fleets gather in the outer system near the orbits of Saturn or Neptune, preparing for the long dark. Ships stretch for kilometers, generations of travelers aboard. Some are biological, others digital consciousness carried as patterns of light in quantum processors. They look back one last time at the pale ember of the sun. The system is quiet, a silence broken only by radiation and wind. It is farewell to a cradle that no longer exists. The final exodus is not a single event, but a wave. Some depart for Alpha Centauri, chasing habitable planets. Others dive into the TRAPPIST-1 system, building new colonies around multiple worlds. Still others scatter aimlessly, seeking freedom in the gulfs between stars. What was once a single species becomes many civilizations, each carrying fragments of the past, each reshaped by the worlds they find. And yet the question remains, is this still humanity? If our bodies are gone, if our minds are uploaded into machines, if our cultures fracture into thousands of divergent branches, what connects them to the beings who once walked on Earth? Perhaps only memory. Perhaps only the shared origin beneath an ancient sun. The Exodus carries both hope and sorrow. Hope because life continues, intelligence persists, the dream endures. Sorrow because the home that birthed us is gone. In the long darkness, travelers will tell stories of oceans that once glistened, forests that once sang, skies once filled with birds. Earth will become mythology and humanity will become legend. Still, there is resilience in departure. To leave a dying star is to defy mortality at cosmic scale. The journey outward is not retreat, but affirmation, the will to live, to adapt, to expand. As the sun fades into a white dwarf, the spark of its children scatters into the galaxy, carrying with them the light of memory. And so the story closes. Earth is gone, the sun is dying, but the question remains, what does it mean to endure in a universe that grows colder with every age? The outro belongs not to science alone, but to philosophy, the reflection of a species staring into eternity. What if you travelled 5 billion years into the future? You would see a cosmos both familiar and alien. You would watch the sun swell into a red giant swallowing Mercury and Venus, and perhaps even Earth. You would drift through a galaxy reshaped by collisions, Milky Way merging with Andromeda stars flung into tides of light. You would walk among civilizations scattered across hundreds of systems, no longer bound to one world, carrying the memory of oceans and forests as stories whispered between the stars. And yet beyond the spectacle, one truth remains. Every star fades, every galaxy grows dim, entropy spreads like a tide, patient and unstoppable. Even the brightest Dyson spheres and the grandest civilizations cannot fight the cooling of the universe. To live in deep time is to live knowing that energy itself becomes scarce, that warmth becomes memory. The cosmos is vast, but it is not eternal, not in the way we once hoped. But pause, that is only one lens. Through another, endurance itself is victory. That humanity arose at all, that consciousness opened its eyes on a small planet, circling a yellow star, is improbable beyond measure. That it spread, adapted, transformed, this is not defeat but triumph. To survive ice ages, supervolcanoes, supernovae and the death of Earth, to scatter into the night and persist, that is meaning enough. Perhaps in the farthest ages we will no longer call ourselves human. Perhaps we will be patterns of thought drifting on starlight, or intelligences woven into black holes. But still the spark that began on Earth will echo. The rivers, the forests, the first questions whispered under the sun, they will remain not as geography, but as memory encoded in minds that look upward and wonder. So what if you travelled 5 billion years into the future? You would not find the Earth you knew. You would not see the sky you once recognized, but you would find something else: the persistence of the question itself, the will to ask, to imagine, to endure. And when the stars grow quiet, when galaxies fade into the long night, perhaps the last voice left in the universe will still ask, what if?